The principle of moments tells us that if a body is in equilibrium, if it's balanced and at rest, then the sum of the clockwise turning forces about a pivot must equal the sum of the anti-clockwise turning forces about the pivot. And that's the principle of moments. You need to be able to explain that principle and write the definition of the principle of moments and explain a simple experiment to illustrate it. So let's have a look at that. So first of all, here's the definition of the principle of moments. So when a body is in equilibrium, i.e. it is at rest or moving at a constant speed, and I'm just going to put here balanced because it will usually be with reference to a balanced system, then the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. And remember that a moment is the force multiplied by the perpendicular distance from the force to the pivot. Okay, so let's take a look at a simple experiment which will help you to illustrate the principle of moments. So what we're going to do is have a play with a ruler and some weights. Let's say that we've got 300 grams here. Now, in weight terms, 100 grams is 1 Newton on Earth. So we know that we've got 3 newtons of weight due to this mass of 300 grams. Now we can find a position where, let's say, 200 grams would balance that 300 grams. So we could write here, find a position where the 200 grams balances the ruler. And let's say that you find that position and it is at 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters away from the pivot. The 300 grams, or the 3 newtons, is at 1, 2, 3, 4, 5, 6 centimeters. So that's 6 centimeters there. The 200 grams has a weight force of 2 newtons. So we've got 2 newtons pushing down there, which is perpendicular to the distance away of 9 centimeters. So let's test out the principle of moments, that the sum of the clockwise moments equals the sum of the anti-clockwise moments. So the clockwise moments are going this way. So we're going to cross the screen. So we've got force times distance. So that's 2 newtons multiplied by 9 centimeters. And let's look at the anti-clockwise moments. Those are going this way. And that would be force times distance, 3 newtons multiplied by 6. And lo and behold, you got 18 equals 18. So it works, and it illustrates the principle of moments. It's a good one to be able to explain if you're asked. So the units, by the way, because this is force, and it's a force of 2 newtons for this guy here, and this is centimeters, we could say that this is Newton centimeters, and this would also be Newton centimeters. It's usual to write the units of a turning force as Newton meters, but in this case we've used centimeters, so that's acceptable. Hope that makes sense. See you in the next flashcard.